First talk is about distributed internet, and away we go.
Hey, so I've already done the introduction, but it's Constantine once again. I'm gonna do a quick presentation on Ethereum blockchains and what all that stuff is. Just wondering, how many people here have heard of blockchains? Half, yeah. How many people know how the blockchain works? Okay, so blockchains are very deep and broad subject. So it's pretty much, start digging in any direction, you find so much that it's impossible to fit all of that into one talk. But my plan today was not to achieve that. I mean, God forbid. But I was not constrained by time. Last time I was not constrained by time. My slide deck was like 42 slides in it, and even that is like nowhere near being complete. Anyway, so what my aim for today is just to give you some idea of what that stuff can be used for. Right? Again, so let's talk about the blockchain. So what is the blockchain essentially? So as I can see, there's 3 people in the room who know what that is. The rest of you, think about it as a database. Right? It's not a database. I mean, it's not nothing. It's something new and completely unique. But it helps to think of it in the context of something that you know already. And given we have a room full of techies, I mean, you know what a database is. Right? And a blockchain is, it's a database. It stores data. It allows you to read stuff from the database and write stuff into it. So read data and write. Set of access permissions, what type of blockchain, what product you're using. But the important part is they're there. And it's interestingly, it's got a massive redundancy set. So the core idea of the blockchain is that it's something that kind of exists on your computer. So the data set, the state exists on your computer and your computer and and what computers do is every X seconds they sort of sync up and query each other. So what's your state of the system? What's 2 plus 2? It's 4, and I've got 4, and he's got 5. Well, there's 2 of us, and there's 1 of you, so we are out of consensus. 2 plus 2 is 4. Unlike database, though, so unlike databases, anything that you write onto the blockchain is, and everything that is accepted by the network, obviously, is there to stay. It's there forever and ever. Essentially, when we're talking about public blockchains, so if you think about Bitcoin, for example, so every single transaction that ever occurred on the network will be stored indefinitely. So you can always go back and prove that certain things happened at a certain time, and they were initiated by certain accounts or certain people. So what it really is, perhaps, is not a database. It's a system, really. It's a network that is ultra secure. And really, blockchains were built. Blockchains are all about security. They're based on a range of economical and cryptographic principles that give it ultimate protection from any data manipulation or any malicious updates or any fiddling with the data. Practically undodosable. It's impossible to DDoS a P2P network that operates the blockchain, even in theory. They are very interoperable. So any computer that subscribes to the protocol of the blockchain obeys the protocol, and this whole sort of network operates on the assumption that every subscriber to the protocol will be able to understand, read, and accept your transactions. And it's infinitely auditable for the reason that I mentioned before, that anything that has been written onto this log, transaction log, that is the blockchain, will be always accessible and always readable. So, yeah, so blockchains are something that is quite easy to understand. Apparently, this is what probably the number one main reason why financial sector is so keen on investing money, time, and development efforts into this utterly complex thing. So as I said already, this is blockchains are a very broad subject, and there's even just from the perspective of just ledgers, just the ledger is Ethereum, ledger is Bitcoin, it's the blockchain, the database that you keep records in. But even there, we've got public blockchains like Bitcoin, like Ethereum, BitShares, permission ones like Hyperledger, or Clearmatics, or Aries, or HydroChain. There's programmable ones like Ethereum or BitShares, and there's fixed function like Bitcoin, Namecoin, and 160 other X coins. They can be open access. Anybody can join the network against Bitcoin, probably. And it can be delegated. Something like BitShares, where anybody, or Ripple, where anybody can participate in validation, but you sort of need to be approved. So it's kind of not open, not closed, somewhere in the middle. Consensus algorithms, proof of work, there's proof of stake, proof of consensus, practical Byzantine fault tolerance, and there are myriad other really complex cryptographic methods just to ensure that everybody on the network stays in sync and it's impossible to attack, unless you obviously will own over 50% of the network, in which case the whole system is compromised. And yeah, there's a lot more different categories. So I think in order to explain what this is good for, the best thing to do is look at use cases, right? And Elias is gonna shed some light on a couple of these. Over to you.
Cool. So as we established, we have it's a decentralized common ledger. So without a central party, we can keep a record of things, of anything really. We can keep a record of any data. And there are some that are programmable, which means without a central party that enforces anything, I can cryptographically enforce certain rules that are programmed onto the blockchain. Now, we've got a whole bunch of companies that are looking into this. We have a few companies there are a few companies that have started trading, that have started using this in the real world. And I'm going to run through a few of them and try to explain what this kind of technology is good for and why it is good for this use case. So one of the biggest stories that you might have heard of recently was Augur. They raised $5 million in a crowd sale through Ether and Bitcoin. This is a prediction market. It's basically bookies online. And you can, it's a system that creates where people can go into contracts with each other and bet on certain events. And ultimately you converge towards a certain likelihood of an event happening, and depending on the information changing, that likelihood changes as well as people change their bets or as people change the contract. Now this is obviously already done in the real world, so I can take money from all of you, and I can, you can bet on certain things, and I, as a central party, can then pay out the funds. This is the first one that is completely decentralized and completely without need for a central party. And the blockchain, the idea of smart contracts that are enforceable within the network without any central party approving it, makes this kind of stuff possible. We've got lots and lots of interest in the area of finance, because we basically we now have programmable money. So I have value on something like the Ethereum blockchain or a similar programmable blockchain. I have value that I can shift around, and I can build applications that run in this space. And one of the proven use cases is crowdfunding, and YFund, for example, is a crowdfunding platform. This is a perfect use case, because traditionally, if you're crowdfunding, again, you might give me money and I hold it. If the crowdfunding is successful, I then give it to, if you reach the threshold, I then give those funds to the person running the campaign. If not, I pay it back to all the users. Again, you have to trust me. And in a blockchain environment, you can have a program not controlled by anyone that sits on the blockchain. Everyone pays their funds into that program. When it reaches the threshold, the program decides by itself to send that money to the campaign, or otherwise send it back. No one can have access to those funds. There's no room for human error or corruption. There are a few other companies that are doing, derivative trading, settlements, clearing between organizations or between individuals, and using the blockchain for that. One of the other interesting things is that blockchains are, as we said, are a database. So I can store information, any data on the blockchain, and I can make sure that information stays there and that information is not altered. So there are a few companies and a few projects that are looking into this. For example, Provenance. They've introduced, or they are working on a system for supply chain tracking on the blockchain. So companies that, as part of the production process for certain products, say a smartphone or a bicycle, whenever they finish a step in production, or whenever a company makes one of the components, they store a unique identifier for that component on the blockchain. They can't take that back afterwards. No one can alter that. And ultimately, you end up with a full list of all the things that are in your product, where they come from. Again, no company can go back and change it when it's not, when they don't like where it comes from or pretend that it comes from somewhere else. So ultimately, the idea of having off-chain assets tracked on a blockchain, that's a use case that's been proven. Internet of Things, blockchains might play quite a big role in this, because ultimately you have lots and lots of devices that have to interact with each other, and decentralized infrastructure makes sense for this kind of stuff. There are a few projects working on applications here. I mean, one of the futuristic ideas is, for example, that your washing machine could hold funds and could order washing powder by itself from another player in the network, and it would get delivered without any central party, without anyone. Airlock is a company. They are working on electronic locks that are directly connected to the blockchain. So you can program rules into smart contracts. And for example, you can say, if these funds are paid, the door is open. Again, without anyone having to approve it or without anyone being able to interact with it. And so, those are, there are lots more applications. It's still really early days. We don't really, in any case, we don't know in which direction some things are developing. Lots of concepts that are being implemented have not been proven. There's lots of research happening. And ultimately, lots and lots of education has to happen for anyone who looks into implementing this, or companies looking at how this changes their business model in 10 years' time. So one of the things that we do, the company that I run, B9 Lab, we do trainings, and we've just developed we've developed trainings for non-technical people to understand blockchain and what that might mean, and how to teach other people. And we've developed a 9-week developer training. Now, we haven't published it yet, but if you're interested, tweet us or send us an email, and we're just trying to figure out what the interest is generally and whether people would be interested in signing up to training. Right? That's it. Thank you very much. Any questions?
Any questions? Yeah.
So is it like a new architecture, the blockchain in general? Is it new, or has it just been around for ages and someone's now got a new take on it?
So the blockchain as a whole is an entirely new thing. The ingredients that went into it, yeah, they existed. Like the field of crypto economics that this whole thing is based on was defined in the 90s, but there's been like no viable or any implementations of the principles described. If you want to look into history, Google for Nick Szabo. He's the guy who kind of theorized all that stuff back in the 90s. But yeah, as a concept itself, it's an entirely new thing. I just wanted to make a comment on the use cases, right? So there was an underlying, but slightly subtle theme to all of this. So there's two types of actors that can benefit from the blockchain. One, like Augur, is where you can do something that you've never been able to do before. Like Augur, for example, a prediction market is a market of financial instruments, binary stock options, which is, as a financial instrument, costs money. So, and this thing was centralized, and prediction markets before Augur have been centralized, generally needs to be operated by a company that acts as a custodial. And in order to do that, you need to have you essentially need to become a bank, and it's only one to be a bank. The interesting thing about Augur is that they do not hold any funds in custody. They remain on the blockchain, technically not owned by anyone. They're just kind of locked in custodial account. Sorry, non-custodial account. They're just locked in some account with a certain logic for access to those funds. So that's an example of something that has never been possible to do before, but has been sort of enabled, powered by the blockchain. And the second type is traditional businesses that want to reduce some costs of running certain things in an organization, like accountancy books, for example. Essentially, if you use the blockchain as a database to keep your books on it, then it becomes infinitely more auditable and requires fewer people to inspect it, etc. So, yeah.
Are you required to download the entire blockchain to audit it successfully and use it?
There are essentially two types. In order to look at everything and to be able to look at so for example, on the Bitcoin blockchain, in order to look at every single transaction and do a full audit, you need to have a full copy of the blockchain. But then, basically, if you can run what is called a light client, in which you can confirm the integrity of the database, so you can make sure that nothing has been altered, and you're looking at the last, say, 1,000 transactions, and everything before that has not been altered, but you don't need the full chain. But for full audit, you will need the full chain.
Okay, I was just curious to see how it interacted with Internet of Things, because obviously embeddeds don't always have 35 gigabytes of blockchain storage.
Exactly. So basically, what you do is you look at you only download a number of transactions that are necessary for you, or you only look at the recent ones that apply to your case, and you just make sure that you look at the hashes of all the previous blocks. So rather than having to look at all the content of them, you just make sure that the integrity is not breached. Yeah.
I heard that you might have issues with the speed of the blockchain as Ethereum grows. Is that something you're
Scalability is a problem.
solution to?
Yeah. So we've got ideas, and they are defined in the paper called scalability paper. It's massive. It's 45-page long PDF written by Vitalik. It's not an easy read. It's probably going to take us at least 3 years to implement all the ideas in that paper, and I think by the time we are done with that, we'll have another 1,000-page long document. Some ideas now to improve it. Yeah.
I mean, at the moment, this the computation on the blockchain is very slow because each node has to execute all the computation in order
Fundamental on the blockchains. Yes.
Exactly.
Every node needs to process every transaction.
Yes. and every node needs to do each computational step. So at the moment it's slow and expensive, but you know, as it develops, it will.
Is there a problem with the crypto side of it? Because when you solve the problem that it's slow and expensive, you also solve the problem it's easy to break the chain because you've broken the crypto further down the chain.
Yes,
So you can't actually rely on it for anything more than long enough to know that it's broken.
yes, I mean there is obviously a trade-off. The reason why the papers are that long and why it's going to be another 2 or 3 years until there is scalability is exactly that problem. That if you make it, if you introduce sub-networks and sub-chains, it becomes easier to crack. So
sorry, that's not my question there is more about the crypto side of it, because by the time you've got the computational side of it sorted so that you can do this mega computation to prove it, the computer speed has moved on, it will be much easier to introduce the fraud in the chain so that you can break it.
oh, I know.
And you will be running the Red Queen's race from start to finish. You will never.
So the computation on the blockchain itself is different from the speed of computation of the nodes in the network. So at the moment it's slow because each computer has to confirm transactions and has to do computational steps. But that is different to the speed of computers that are nodes. So computer speed of the nodes increasing doesn't really pose a problem. It might even slightly improve the scalability.
Singularity does pose certain limited. It's not like
Yes.
can still work even in the conditions of singularity.
Quantum computing might also pose a problem.
Yeah, that's what I meant. A fixable problem too.
Yes.
For a given blockchain implementation, if the developer of that wants to upgrade the nodes in the network blockchain, doesn't that expose an inherent weakness in one thing? Is there an upgradability path?
It's challenging. Every time we need to release a new upgrade to clients, it's always a bit of a challenge to do that because yes, as you said, it's up to. No, it's not like a website where you can just roll out a new version, you hit the forward button, and boom, everybody's forced to use the new version. Here, there's generally a couple of approaches to that. You do it by forking. There's so-called hard fork and the soft fork. The soft fork is where developers go, okay, so we need to release a new version of the protocol which is incompatible with the old version of the protocol. So we just make sure to tell everybody that please switch to the new one. And as soon as the majority of the nodes switch to the new version, then the minorities just sort of ignored.
Does the trust not then track back to the developer?
So we're calling the systems trustless, but there's no such thing as trustless. It's not just the developers that need to trust. It's your machine as well. It's hardware. It's the software that you run your OS. So there's always going to be some element of trust. It's just massively reduced these days with that stuff. And besides, everything that we ever built is open source, MIT and GPL.
Of course. Each transaction, how big is a transaction?
Great question. So with Bitcoin, they're all the same size, right? Because they're all fixed logic. Whereas with Ethereum, your transactions can execute code, right? And the amount of that code, the complexity of that code, it can be pretty arbitrary. There's certain limits to it, but so it depends. It depends on what sort of your. I mean, it can be anywhere. I actually don't know in terms of bytes, but we have this interesting system called gas where you pay for the computations that are involved in your transaction, and the more you need to compute, the more you need to pay for. The more you need to pay for that transaction. But it varies a lot more than in the case of Bitcoin.
So how big are the Bitcoin transactions?
I have no idea.
Okay.
I know they can do up to 7 transactions per second or 4 transactions per second. That's the total
Right.
capacity of the network. So right now, the Ethereum, you can do 12 per second. Which doesn't sound like a lot, but for now, that's sufficiently, that's good enough. And in the future, we're planning to go tens of thousands per second. So the scalability changes there.
Any more questions?
I was just wondering what a smart contract looks like and what the follow-up to that is.
Do you know what JavaScript looks like? Imagine JavaScript, add strong typing to that, replace the word, it's just like a mix of C++ and JavaScript. So C++, that looks a little bit like
horrible.
JavaScript. I would disagree with that. I love JavaScript. But yeah, and replace the word class with the word contract. So yeah, you got a smart contract. But yeah, the bottom line is it's just code, high level.
And eventually it compiles down to
Ones and zeros.
yes, but kind of intermediary step is it looks similar to assembler, which so it eventually runs on the Ethereum virtual machine, but the abstraction level is something that looks similar to JavaScript.
Anybody else? Okay, so one more. James.
So all these benefits you've talked about of blockchain in sort of terms of security, they only come if you have a really wide, diverse network of
Yes.
people who are running nodes.
Yes.
And so how do you motivate people to do that in all these use cases? So in Bitcoin, if I think correct, I'm not an expert, but do you not have a little Bitcoin transaction fee that
Yes.
sits on each transaction, and that's how you motivate people to run Bitcoin nodes? But in all these ones, how do you motivate people?
Right now it's exactly the same. Except the only difference is that the transactions can execute code and therefore the transaction fees, they vary. But yeah, there's mining as well. We're using proof of work for now. It's a sort of intermediary thing. We're going to switch to proof of stake in the future. But as it stands right now, you earn a little bit you earn 5 ether for mining a block. So that's one thing, and by mining a block, you basically validate all the transactions that went into the system. You check their correctness and the fact that they compile, and for each transfers, you check the balances and etc. You just check for the validity and create a new entry on the blockchain. And also, you get a little fee for every transaction. And unlike in the Bitcoin system, you can't have transactions. You can't have free transactions. So on the Bitcoin network, technically, I can send a transaction that's 0 fee. It will take a couple of weeks for it to get accepted on the network, but you can do it. In Ethereum, you can't.
Any more? Okay, I'd like to thank you for. Oh, good. Yeah.
How robust is this scheme against aggressive interference from government agencies?
Aggressive interference from the government agency.
Quite determined to overcome any ideas you want.
So yeah, my exposure to government agencies or any of their interference has been nil.
I mean, you have a certain cost involved with mining. So if you basically if you want to capture the network and you want to be able to change it arbitrarily, you need to have enough miners, and this is for a proof of work network like Bitcoin. So I have to have, in this case, in Bitcoin's case, more than 51% of the network in order to be able to fork it into the direction I want it to go. And that will definitely be noticed. So you're giving away the fact that you are that you have control of the network by the fact that you have control of the network. And if it's a pretty tightly knit community. So if suddenly a big chunk of the network is unaccounted for in terms of the computing power, then certainly it will be known. And you avoid, or the step of avoiding this kind of interference would be to use proof of stake, which means you only let you either choose delegates that can approve transactions, so you choose a set of people who can validate transactions, or in the proof of stake case, you only let people validate transactions if they have a large enough stake in the overall success of the network. So they own lots of the tokens, for example, which means...
Thank you. So on the technological level, yeah, if they really wanted to attack it, then they probably could. But today, the total hashing power of the Bitcoin network is more than the world's top 500 supercomputers put together. It's pretty expensive. The Ethereum network is not as large, but it's sufficiently large. But that's on the technological level. In terms of motivation, I don't think they're that interested in actually breaking it. See, with Bitcoin, we had this so anti-establishmentness and anonymity and anti-regulation thing going, but that's mainly due to I think that's mainly due to technological limitations of Bitcoin itself. It can't really do much except send money anonymously when you need to buy certain things. When you have a programmable blockchain, you can build really complex architectures for exchange of funds and different instruments, and there's a lot of solutions to anonymity and identity and whatnot. So actually, you can not only build regulated systems with regulated environments, but also we can sort of, if we really want to, we could end up in an ultra-regulated society. But anything that you do financially will be always visible to the appropriate agencies.
Oh, wouldn't that be fun?
That would be awesome.
And also one of the things to note is that with the blockchains, because all of the data is available, so you basically have a different, almost different social contract when you're entering into building something on it or operating something on it. So in an existing system, it's all data is kept with a third party, and we're kind of hoping that maybe the NSA is not looking at it. Probably they are, but we don't really know. Maybe our data is sold or not. On the blockchain, most of the blockchains are pseudonymous, so I have to link whatever identity I have from the blockchain with my personal identity. That's not built in, but the rest is completely available. So I can, once I find out the identity, I can then trace all the transactions that have ever happened to and from that account. So basically, the privacy question is a very different one because it's all visible. So you have to solve privacy questions differently.
No, we will have to stop.
Okay.
Okay, thank you very much for the talk. So with that, our next speaker is here, so you're not going to get me doing half an hour of interpretive dance. So you have 10 minutes to go for a ciggy, go for a wee, whatever, before the next talk.
Yeah, the guy said, I'm good at that. Well, that's one thing.
Yeah.
Okay, folks. Time for the second talk. Right, okay, our second speaker has arrived from many days camel ride. So all I want to say is here is Patrick.
Right. So I'd like to talk about what Maca. I think I change pronunciation every time. Rather than think of a good name, I just sort of went for a deliberately Googleable but just bad name in the style of Woolmanger and all those things. So who am I? I have internet details. I went to uni here, and I went to London for a bit, but it's a bit rubbish. So now I'm back in Scotland, maybe in Edinburgh, maybe not. Who knows? Anyway, I'm for hire, so I don't know. Tell your boss or your mum or whoever. Right. So what is Puff Macro? It is. This is the very clever acronym. Ubuntu variant with package management and configuration over HTTP. And it is basically just a solution to a number of things I like to moan about. I've tried to think of everything I hate about sysadmining. A list I'll go through, and then make a thing that removes all those things, and maybe creates new things to hate, but just different trade-offs. So that's what I'm playing with. Oh, and it's implemented as a Fuse root file system that does sort of everything under Slash. And it kind of enables you to use webby, cloudy, whatever tools and techniques to do your sysadmin. There'll be a demo. So what do I rant against? I mean, this is standard boring. Locally hacked configuration management. Everyone knows it's a bad thing. We all do it. But it's a rabbit hole. And then I suppose there's also the enterprise version of this, which is persisting your changes to a Word document, which also is definitely worthy of ranting against. So this is, traditionally the next step up is scripted configuration management, which actually, I do quite like, but obviously you run into issues where if there's a change to the script, then do you re-wipe everything from scratch, or do you, or if it hiccups up halfway, can you run the script again? I mean, who knows? It depends on your script, and the more things on the box, kind of the uglier this all becomes. So therefore, we all seem to settled on convergent configuration management with your puppets and CF engines and chums. Again, I don't like this because it seems a completely bogus premise that that computers are in this kind of unpredictable state. They're deterministic. You know how you got them there because you computed at it and put it in that state. And if something goes wrong, then why should something go wrong? I find convergent configuration management is kind of like working with a number system and not really knowing what zero is. And you can do, I'm sure, lots of clever things with deltas, but you're working on this base and it's a bit mushy. And, I don't know, it's pragmatic, I guess, in some cases, but I don't know. I don't like protocols other than HTTP. I mean, HTTP does run the world, and yet still things like, Puppet will have its own like weird thing that another server for you have to learn how to use, and another. Well, I suppose an entire another stack for your sysadmins to keep care of. So we keep making new servers, new protocols, and I suppose there are new ways to debug these things. They've mostly already been solved in HTTP, and if it's not, then maybe that we should be. They have already been fixed. It's just we've got a wealth of knowledge, so let's use it. In making a distro, I guess something new, you're inevitably going. Well, not inevitably. I've avoided it. You might have to compile a load of stuff that you didn't write and end up going a bit deviant compared to like what the community's using. You see that in things like Nixos, and I don't know, can always have a bit of a Gentoo rant. Someone else use that? Who knows? I hate it when your package manager downloads a load of stuff that because it thinks you might use it, and then it doesn't ever use it. I mean, for example, how many people use bin factor? How many servers over the globe is that installed on? Just eating up those few little kilobytes of space. Money and Mickle, Max and Muckle and all that. It's killing the planet. extraneous tools and libraries. I suppose what I mean by that is even things like your package manager, your apt-get, there are all these tools, and if you want to automate it, if you want to script it, then is there a Python binding to X? You know, maybe. And then what if you're using something new and quirky? I mean, I'm trying to say, in what I'm doing here, I'm trying to just find ways to minimize, you know, what I need to implement and what people using my stuff need to implement. I like to rant about most languages. I think probably most people in this room do, because they've all got their trade-offs. Yeah, I've got a special little hate here for DSLs. Well, I mean, actually, I've got a love-hate thing with DSLs. I think they're very powerful, and that's obviously a lot of the time the best way of expressing your problem. But it's more stuff to learn and more libraries, I guess, to work with. And I've got a love-hate thing with Shell. It's a brilliant interface. I quite like it as a UI, but that's about it. And that's still kind of, those are dirty words. Like why are there so many init scripts and things like that written in this language? And it's all written in this kind of subset of shells so that you can use different shells. I mean, why don't we just, if you just use Python, then that would be more portable. It's all a bit backwards to my mind. Yeah, so I just mentioned init scripts. I mentioned them again. I don't trust init scripts by anyone other than me. I don't like them anyway. So yeah, now think of all these things. Think of a distro that somehow manages to sidestep all of these kind of things that are a bit rubbish. That's what we've got. So how does if anyone does have any suggestions, then please see me at some point. How does it evolve? Declarative configuration. Everything you do is in JSON. I'm sure that's got its own expecting a boom maybe, but it's often enough pragmatic choice. It's got bindings in various languages that are compatible enough to use. And again, declarative configuration, which is what a lot of the convergent things have kind of all agreed is the right way to do this. I use HTTP for everything, which sounds very boring, but maybe I'm using it for things that you wouldn't have thought of. I said that. I'm abusing Unix as best I can, better than I thought I could, to do things. You'll see. It has what I'm saying, all-seeing knowledge here. You can't write a file to the file system without the kind of without it. I had it right in the car. Knowing about it. It actively monitors your processes. As I suppose init does or whatever, but PID files. Why didn't I add PID files to that previous thing? PID files are a really weird mechanism to me. I mean, there's this process sort of data in memory, and then why are you writing it to disk? And they don't have, they don't sit right to me, so it avoids me. So this starting the box is installing the system. We've all seen systems that can take a long time to install. I'm hoping this should take less time to install. But again, because it kind of assumes that every time you do it, it's completely fresh. You can make some slightly different trade-offs. Oh, to avoid the recompiling thing, I'm just unpacking and repacking Ubuntu dev files. So technical details. So what I've got is I've got a Python script that takes a dev file, packages it, gets all the files out, and spits out the contents as all the individual files to S3. And it then creates a JSON descriptor, which I put on GitHub, just in my repository. And yeah, what it takes in, so it takes files in. The files in can either be a dev file or things that you can tinker around with yourself to produce these things. If you really wanted to, you could create the JSON script yourself, but it seems like a bit of a. I did that for a while, but it seemed easier to not. As I said, it's also a Fuse file system, which I wrote in a Camel, which pulls a sort of master package descriptor at boot, and that recursively downloads other packages. I suppose the packages, as I said, are just descriptors, so it should be a fairly lightweight sort of downloading process. And then when you need a binary, it'll pull it off S3. Does all this, and I've implemented a custom init that talks to the file system over some pipes to start daemons and what have you. I think I've said that. So if you want to start the thing, then this is just running a QEMU instance. So I probably should have put in a Windows. So it starts that. It starts. It's got a custom init RD, and then the init RD it does very minimal amount of stuff, just setting up using the HCP to set up the network, and does the the file system pivoting kind of stuff before it starts, and then it gets starts downloading all these things. It got a initial kind of master descriptor, which we'll have a look at in a minute, and then in turn it's kind of downloading all of these. I suppose in theory, if there are any, so it's done all that, and now it's downloading some binaries because I just happen to know this is it starting SSH. So we can now SSH in. And you will be able to see this looks obviously like a fairly standard Ubuntu thing up to there, where it's got the latest BBC News tweet. And the reason it's got the latest BBC News tweet is, if you have a look at ECITD, that's just a file that happens to have to read from a URL source somewhere else on the internet. So do you want to go to the next slide? Actually, I'll open that. Page down. Yeah, so as I said, so this is the master package descriptor that I mentioned. I've done the dirty keys as values thing. I apologise sincerely. We see so everything has a stat, which is the kind of what's returned when you put stat on the file system. It has a deserializer. You can see at the top directory because this is just a slash, and then file is also exists in everything because and that is the argument really to the deserializer that's kind of passed, and it goes and does things with it. So we'll just skip down a bit to yeah. So there's the you can look MOTD. There's an ETC kind of key up there somewhere, and then there's this BBC News thing, which is a configure service I made on last week install. I'm going to go to the slide.
I see one clicking. Right, next one.
Okay, sorry, this is my sort of prompts as well. So do you want to do some of those things? So,
So what have we got? I'll kind of do some. And you just
how do I make this?
drag it over on the right. Drag the tab. Oh, you got a cat in front of your CD.
Two slashes.
That's okay. I know. You double slash and stuff.
What, you can drop double slash. Fine.
Packages. There you go.
So let's have a look at the bash package. I've got yeah. So in /control is sort of a meta directory hierarchy, which is made for this, and that's used for interacting with underlying things. Then there's packages. There's a list of a load of packages. We'll have a look at that. And then for each individual package, there's a directory. So we can use look at contents to see what's in it. And this is obviously in the slash as well. And then it's just convenient, really. Oh yeah, loads of dependencies. So in this also, we have, if you look at the top, it has control packages, base files, and Debian utils. So when you install it, it'll download, it'll create that directory, control packages, base files, and then when it does that, that'll trigger it downloading and installing that package. And you can imagine that sort of works recursively to do things. So let's use some of that to install.
I think you were maybe one directory too far.
So now we should be able to see when it does that, it triggers it to download Python, well, all the Python 2.7 and then it's getting all that stuff. It also, you can see it's nuking stuff. It's got some HTTP, it respects HTTP caching headers. So you can do clever things like, well, let's see if that BBC News thing changed. I don't remember what it said before. Let's pretend it has. So yeah, we should now be able to run Python 2. So I was going to show you it not running anyway. Just trust me, it didn't run before. So we also I've also the way I deal with init scripts is again through this kind of file system. So how on earth I'm going to type this without wanting to punch someone, I'm not really sure. Okay. Trust me, if I did all that stuff and then went to localhost 8000, it would start right. We can have files owned by multiple packages. In post-inst things, you know, there's often lots of scripts that kind of fight over ownership things. For example, password.d. etc password. So I've worked around that by creating files in etcpassword.d / root or whatever, and then that's all amalgamated into etcpassword. So it kind of allows this kind of shared ownership property. I'll show you about back right short time. If we want to do something, cool. If we want to do something like that, then then yeah, it just throws a wobbler. I really should do a better job of throwing the right exception for the right thing, but I suppose as far as I'm concerned, the important thing is that it's not like even having a firewall in place. Writing to a file that's downloaded in this kind of way is completely a meaningless operation. It just doesn't support it. So I think I've done thrown an exception, a false assertion on something somewhere. It's just not possible. So you can't tamper with things in various ways, which I think is quite a good property. I can't using your keyboard anymore. You can also export your entire file system, including all the packages, and even if you write to /tum/foo, that is kind of, you can export that in the same JSON package format that that all the packages are in. So you can, if you're messing around, do this, and then you could make that a new system thing to install another, somewhere else. Again, this saves the endless rampage that bin factor has on our planet's disks, which I suppose is a good thing. So by doing what I've done here is I've kind of turned things slightly around a bit, and I've made the OS, the distro, whatever, is a web client. SAs, sysadmins can become web developers if you're some kind of, and so we can all use the tools that we know and love or hate, whatever, as long as it's webby. So if people do like Perl, I'm sorry, but but you can use Perl CGI, right? Which everyone knows how to do. Everyone's got a framework that they can tolerate, whether it's Flask or CGI bin or something. Even you can have things that use. You can also, if you just want to store raw JSON, then you can use Git and SDLC, and pull requests and ways to collaborate over these things. Which, if you think of in the Ubuntu world, that you've got all these PPAs. Maybe instead of doing that, we should be using pull requests or whatever. Yeah, so I can think of lots of things to do, bits and pieces, but I don't know. I think it's a neat proof of concept happening at the moment. It's even neater if you use a keyboard that you like with a screen you can read. But if anyone's got any interest, then let me know. I've still got the package just as the repository just as private at the moment. But I don't know. I'll change that. But yeah, let me know if you're interested.